Well, hello, cohorts. This is Carol.
And this is Sandra.
And for our share time, we will explain Pearson's R. Pearson's R is commonly called the coefficient of correlation. We use Pearson's R when we want to know whether two variables are related to one another. If they are related to one another, Pearson's R can tell us if there is a strong relationship or a weak relationship. To calculate Pearson's R, both variables must be at least intervally scaled.
The formula for Pearson's R, which calculates the relationship between two variables, x and y, is seen here. Pearson's R is the covariance of the variables divided by the product of the standard deviation of each variable. An equivalent formula is seen here. No worries, we'll be showing you how to calculate this over the next few slides.
Pearson's R is a statistic that helps us to understand the strength of linear relationships between two variables. The closer R is to +1 or to -1, the stronger the relationship is between the two variables. When R is close to 0, the relationship between the two variables is extremely weak. As you can see from these scattergrams, the first one indicates a positive correlation that is fairly strong. The line of best fit captures many of the asterisks in the scattergram. The second one shows a negative correlation that is even stronger. Finally, the last scattergram shows a weak or non-existent correlation between the two variables as the R value is very close to 0.
Can you calculate Pearson's R? The table shows the scores of 5 participants on two variables. We want to know the relationship between the level of difficulty of an assignment, x, and the number of headaches a doctoral student gets each day, y. To calculate R, we must first subtract the mean of each variable from each individual value, calculate the cross products, and then find a sum. This will be the value we place in the numerator of our formula. Then we will subtract 1 from the number of participants and multiply this value with the product of the standard deviations of each variable. This will be the value we place in the denominator of our formula. By using this calculation, you can see that the value of the numerator is the sum of the cross products, 14. And now we find the value of the denominator by subtracting 1 from our total number of participants and then multiplying this value 4 by the product of the standard deviations of each individual variable. The final quotient, 0.9899, represents the strength of the relationship between the variables.
Since R equals 0.9899, which is very close to 1, we see a strong positive relationship between the variables. We know that the line of best possible fit will capture most of the asterisks in our scattergram. In our scattergram, each asterisk represents two values for a given participant. For example, the level of difficulty of math assignment was 5, and he experienced 7 headaches. On the other hand, Felicia, with a difficulty level of 1, experienced 1 headache.
As you can see, the line of best possible fit hits most of the asterisks, so this would indicate that there is indeed a strong positive correlation between the difficulty level of the assignment and the number of headaches. You did it! You calculated Pearson's R.
For more information and web resources about Pearson's R, we have included links in our handout. One of these links is a YouTube video which demonstrates how Pearson's R can be calculated using SPSS. We hope you enjoyed our presentation and now have a better understanding of Pearson's R.
We know we did.